Hello, in this video I'm going to be explaining the triangle of opposition. If you've not yet watched the video on Aristotle's square of opposition, or you are unfamiliar with the square of opposition, you may want to watch that video first. Logicians use a very strange definition of the word sum that is really only specific to them. They define it as meaning at least one. Now initially that may seem like that's okay, but it results in some very strange claims being considered true. For example, if you were to say some dogs are canines, then in logic that's considered true because it really is the case that at least one dog is a canine. Similarly, if you were to say some dogs are not elephants, that also is considered true in logic because it is the case that at least one dog is not an elephant. But why would we use these more restricted claims when in reality we know that the universal claims are the ones that are true? Everyone knows that all dogs are canines, so why would anyone ever say some dogs are canines? And in a similar way, why would anybody say some dogs are not elephants? If you were to say that the next visit that you took to the zoo, people would look at you very strangely. So could we come up with a better definition of sum that is more intuitive and more similar to how it is used outside of logic? I think that we could, and the definition that I would propose is not all and not none. If we use this definition of sum and we analyze the relationships of Aristotle's square of opposition, we realize that it would have a dramatic impact on those relationships and that those relationships would be pretty dramatically altered. For example, what we would notice is that some SRP and some SR not P would always have the same truth value with this definition of sum. This would mean that the standard relationship in the square of opposition of being subcontraries would not actually hold, because according to the square of opposition, they can't both be false at the same time. But in this case, they would both be false at the same time whenever one of the universals is true. So that's the first major difference. Now you wouldn't necessarily have to conjoin some SRP with some SR not P. You could just leave one of them implied. But since they do have the same truth value, you can combine them if you want to. Okay, another relationship that is different is that subalternation would not apply, because it wouldn't be the case that all SRP implies some SRP if, in fact, we use this definition of sum, because the definition says not all and not none. So, in a sense, all SRP couldn't imply some SRP without also implying some SR not P, and obviously that would be self-contradictory. In a similar way, no SRP couldn't imply some SR not P without simultaneously implying some SRP, which of course would also be self-contradictory. And the particular statement does not imply either one of the universals either. So if one of the particular statements is false, or in other words, I guess if the particular statement is false, it wouldn't imply either universal. You would know that one of the universals had to be true, but you wouldn't know which one. And that actually leads to the next relationship. So the modern square of opposition argues that none of Aristotle's relationships hold except the contradictory relation. But I actually believe that not even the contradictory relation would always hold. As I mentioned earlier, some SRP, if some SRP was false, then that would imply that either all SRP is true or no SRP is true, but we wouldn't know which one. And this would actually be true for all three statements. So the relationship that the three statements have to each other is that one of them, exactly one of them, has to be true, and the other two are going to always be false. And this would be true for any statement, no matter which categories you're using. Now, we're assuming that those categories talk about members that actually exist. If they don't actually exist, then the claims wouldn't have a truth value for the actual world. But otherwise, one of those three statements is always going to be true, and the other two are going to be false. So in a sense, it's kind of like all three statements are contrary to each other, meaning that if one is true, then the others are going to be false. As far as what the contradictory relation actually is, so the contradictory of all SRP would be either some SRP or no SRP. This should be understood as a exclusive or statement, meaning that it can't be the case that both of them are true. It would have to be the case that it's one or the other. But we would not know which one it was simply from knowing that all SRP is false. So this would be the true contradictory relation. We couldn't say that either of the two categorical statements would be a contradictory. It would have to be either one or the other. Now, the interesting result about this is that suppose that no SRP is true. Well, if that's the case, then either some SRP or no SRP is also going to be true, because this second portion is going to make this claim true. Okay? And also, this statement right here, the contradictory of some SRP, is also going to be true if no SRP is true, because this portion of it is going to be true. So what we end up with is that the only contradictory statement that is false is going to be this one, either some SRP or all SRP, which stands to reason because it would have to have the opposite truth value of this statement right here. So what we end up with is that exactly one of the three categorical statements is going to be true, and exactly two of the contradictory statements are going to be true, and they're going to be the contradictory statements that are close to the categorical statement. Okay? Now, what are some of the advantages of using this definition of sum? Well, it's a lot more precise. We're going to define all as being 1 or equivalent to 1. We're going to define none as being equivalent to 0, and some would be equivalent to some fraction or decimal point that is greater than 0 but less than 1. So it has to be something in between those two. Okay, so sum is going to be a generic term with an indefinite value, and it could stand for any number of more specific quantifiers. So one advantage of using this definition of sum is that some of these statements that are used here are hard to translate into standard categorical logic. For example, if you say almost all SRP, then that seems to imply both some SRP and some SR not P. It couldn't mean all. There's no way that almost all SRP could mean all. It also couldn't mean none. So it seems like it implies both particular statements. And this would be true of all of these claims. So almost all, most, many, the majority, more than half, about half, less than half, the minority, not very many, few, almost none, and a whole host of others. None of those seem to imply either all SRP or no SRP. They seem to imply some of both. Well, this is going to be exactly equivalent to my definition of sum, which would be not all and not none. So this would be much easier to translate these statements into this form of, or this definition of sum. And I believe it's a much more accurate definition of sum and something that is much more intuitive and similar to how the word is used outside of logic. So this would result in, I believe, a more accurate definition, and also these claims would be very easy to translate into this version of the word sum. There's much more that I would like to tell you, but if you're interested, I will just let you go ahead and read about it on your own. You can download a copy of this essay or this written work that I have here at the website listed below. Thank you for your time.